8 and 13, which I think is what I assigned. So let's just, there's so many different ways of doing this. It's whatever you feel comfortable with, and eventually you're going to be comfortable enough that you can pick and choose the easiest route or the more efficient route. It really doesn't matter. It's all dependent on your comfort level. So first part here, I mean, I'm looking at this guy here, and maybe you want to, rewrite the whole thing and throw him to the numerator and make that exponent positive. That's definitely a way to do it. What I'm going to do is too many parentheses, and there's too many, exponents, right? So I'm going to get rid of that 3, get rid of that 2, and get rid of the negative 3. And one way to get rid of those is to multiply. Do the expander, we'll multiply these two. The 2 was a negative 6, the 2 was a 4. There's a 1 here. The negative 3 was a 1, and negative 3 was a negative 2. So I'm going to do that first. And then I'm going to see if you're a negative. I'm going to switch where you are. If you're in the denominator, you go to the numerator. If you're in the numerator, it becomes the denominator. So I think that could be, for me, I think, the easier path. So that stays. And again, you could have gone ahead and, of course, know that 3 to the negative third power is going to eventually come down here. You could have done that right off the bat. I'm just going to leave it where it is. Let me get rid of these parentheses first. So those two fellas stay where they are. That 3 is going to multiply with negative 3 and then with the negative 5. So I'm going to get v to the negative 9 and w to the negative 15th. Done. At the bottom, I'm going to get u, and it's negative 6 times 2 is negative 12. V to the second times 2 is v to the fourth. And then there's a 1 over here. So v to the first power times negative 3 is v to the negative 3. And w, negative 2 times negative 3 is positive 6. So that's, notice that these are all gone. I think that's better. For me, that's better. So now what I'm going to do is, again, rewrite this expression here, where I'm going to get rid of the negative exponent. So 3 to the negative third power, I'm going to throw him down here, and the exponent becomes positive. U to the negative fifth numerator is now the denominator, again positive. V to the negative 9, same thing, comes down. And the w comes down, and they all have positive exponents. So all these 4 factors came down here, right? Because they were all negative exponents. So now they're all positive. Good. U to the negative 12. Well, it's a negative exponent, so let's throw them up here. V to the fourth is positive, so please leave them where it is. V to the negative third, go upstairs, becomes positive. And w to the sixth stays in the denominator. All right, we can make this a little bit prettier or simplify a little bit. So u to the 12 and v to the third power will stay as it is. There's nothing to do with them. 3 to the third, I can change to 27. This u here, oh no, there's no other u, so that just stays at u to the fifth. But this v and this v to the fourth, I can combine them and make them v to the 13th. That w15 and w6, right, I can keep the base, add the exponents, and that becomes w to 21st. So again, it looks prettier. I think we have one more step. We can simplify. 27 is going to do absolutely nothing, but u to the 12 and u to the 5th. So think about those two first. Think about what that is. So u to the 12 divided by u to the 5th. So one way of looking at it is this way. Keep the base, subtract the exponents. 12 minus 5 is u. So I get u to the 7th. Another way of thinking about this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 u's being multiplied with themselves, and then 1, 2, 3, 4, 5 u's in the denominator. Simplify, right? If you simplify, what do you have left over? 1, 2, 3, 4, 5, 6, 7 u's here. So notice that this answer, they match, right? So u to the 12 and u to the 5th becomes u to the 7th, but in the numerator. Repeat the process with v3 and v to the third power and v13. So this one's a little bit different. So we have v to the third power divided by v to the 13th power. Keep the base, subtract the exponents, we get v to the negative 10th. Now, what is v to the negative 10th? Well, let me write it another way. So 1, 2, 3 v's, and then 13 v's in the denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Again, simplify. And what do I have left over? I have 10 v's in the denominator, which is this, right? Isn't v to the negative 10th power 1 over v to the 10th? And that's what we have here, v to the 10th. So this and this simplifies to that. And then finally, w to the 21st power. But this looks like my final answer. Again, not the only way to do it. It's one of the ways you could have done it. This problem, let's see. If I were to do this, I would get rid of this guy first, probably. And to get rid of this guy, right, to make it into a positive exponent, we're going to rewrite the expression. Make it a positive exponent. By making a positive exponent, everything's going to switch a little bit. So these guys, the numerator is going to become denominator and the denominator. And I'm going to write a little dot there just because I think we forget sometimes. There's a little multiplication sign there. Times 2 times t times u to the negative 3. So that's what that says. And notice that I removed the parentheses. Why did I remove the parentheses? Because there's an exponent of 1 here, an exponent of 1 here. And then if that 1 multiplies everybody by everybody, right? 1 times 1 is 1, which is what I have here. 1 times negative 5 is negative 5, which is what I have there. And 6 times 1 is 6. So everybody, because the exponent is 1, right, came out exactly what they were inside the parentheses. So now that's what I have. So step 2. You can simplify, right? You can simplify and then raise it to the third power. It's up to you. Or you can take the time now and multiply that 3 times every exponent in here and then simplify your expression. It's really a matter of choice. It's really a matter of choice. What would be my choice? Well, I'm going to simplify a little bit before I raise it to the third power. Okay, so 3 to the first power stays as it is. T to the negative 5 power, I'm going to throw it downstairs, becomes positive. Check, check. U to the 6 stays up. 2 stays up. Let me put a dot. I'm going to multiply that later. T stays up. U to the negative third power, it goes down, becomes positive. 4 is in the denominator, stays in the denominator. T to the negative second will go up. And then u to the 5th will stay down, right? So if you are positive, you stayed in the denominator. If you're not positive, I threw you upstairs to the numerator. So again, not raising this to the third power, but let's see if I can make that a little less messier. I can combine 3 and 2, and I can call it 6. And then I can multiply t and t to the second power, right? There's a little 1 over here. I can call it t to the third power. Keep the base out of the exponents, and then let me not forget the u to the 6th power. At the bottom, I have 4. Let me write the 4 over here in the front. And then I'm going to write the 5, t to the 5th power. And then u to the 3rd power and u to the 5th, I can combine and call it u to the 8th power. I'll raise to the 3rd power. Still not ready to raise it to the 3rd power. So let me see if I can simplify it one more time. 6 over 4, also known as 3 over 2. Check, check. T3, T5. So that is 3 t's in the top and 5 t's at the bottom. 3, 4, 5. I simplify. Where do I have t's left over? In the denominator. And how many of them? 2. So that's t to the 2nd. U6, U8, and again, we have 6 u's in the top being multiplied, 8 u's in the bottom being multiplied. If you cross them out, you're going to have 2 left over in the denominator. There's nothing else to do. Now I can take that and multiply it, and raise it to the 3rd power. So it's this inside the parentheses multiplied by itself 3 times. Otherwise, so what we end up getting, and then if we multiply this times the little exponent of 1, the 3 times the exponent of 1 from the 2 times the exponent of 2 times the exponent. So we get 3 to the 3rd power, 2 to the 3rd power, t to the 6, because 2 times 3 is 6, and u to the 6. Take one more step. 3 times 3 times 3 is 27. At the bottom we have 2 times 2 times 2, which is 8. T to the 6, u to the 6. So you definitely could have done that. Okay. I'm thinking of a different way of doing this. So, and again, so many ways you can approach this. What if you decided to first change at least this, right? Change to a positive, right? So you have what I have right now, and then you said I want to apply the expander rule right away. So you can take that 3 and multiply that 3 times every exponent inside the parentheses. So you would have 3 to the third power t to the negative 15, because negative 5 times 3 is negative 15, u to the 18th, right, 6 times 3 to t, 2 to the third, t to the third, and u to the negative 9. So if I multiply, right, I multiply this 3 times everybody over, and again there's a 1 here, so 4 to the first, multiply the exponent is 1 times 3, I get 4 to the third power, t to the negative 6, and u to the 15th power. So, right, and that gets rid of this guy right here. It's gone. Now it becomes same thing. Can we simplify a few things? So 3 to the third power is 27. I'll put this 2 to the third power right next to it. I'm going to write an 8 right here. And then this t to the negative 15, I'm going to throw them downstairs. It becomes positive. U to the 18th will stay upstairs. T to the third will stay upstairs. And u to the 9th, I'm going to throw him downstairs, right? Because it's a negative exponent. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6. There are my 6 factors. And then 4 to the third, allow me to write that as 64. Check. T to the negative 6 goes up, becomes t to the 6 positive, and u to the 15 stays in the denominator. Okay, so let's see if we can do this correctly. So again, we can simplify. 8 and 64 becomes 1 over 8, so 27 and 1 over 8, right? Because that's a 1, that's an 8. T's, I have 15 T's here, and on the top I actually have 9 T's, right? Because t to the third power. So actually, you know what? Let me write that. I have u to the 18th, t to the 9th, and at the bottom I have t to the 15th and u to the 24th. That's what I have. And then if I simplify one step further, let's do the t's. I have 9 t's on the top, 15 t's at the bottom being multiplied. If I simplify, right, I'm going to get t to the 6 at the bottom. U to the 18th is 18 u's being multiplied over 24 u's being multiplied. If you simplify, you're going to get 6 u's at the bottom. So again, a different way. I don't even know if you would have done the problem in either of the 2 ways that I posted. But again, as long as eventually you get this, right? So use the rules, the laws of exponents to your advantage, whichever one makes it more efficient for you.